Hi everyone. So today we're going to learn about multiplying with negative exponents. From last year, you should remember hopefully that when you multiply with the same base, so I'm looking at example 1 where it says x to the 5th times x to the 3rd. The x is the base and the exponents are 5 and 3. In multiplication, we bring that base over and we add the exponents. So this would be x to the 8th power. The reason this happens is, and you guys do this usually in like 6th and 7th grade, if you break it down, x to the 5th is x times x times x times x times x. It's 5 x's multiplying with one another, times x to the 3rd is x times x times x. So altogether, there are 8 x's multiplying by one another. Okay, the shortcut is you just add them. Now, if you have, in example 2, if you have coefficients, so -6 is a coefficient and 3 is a coefficient. The coefficients act like regular numbers, they just multiply. So we're going to multiply the coefficients and we're going to carry the base x over and we're going to add those exponents. 8 plus 4, add the exponents. So our answer to this would just be -6 times 3 is -18, and this would be x to the 12th power. Okay, in example 3, you have just more variables. So maybe take a minute, pause the video, and make sure you can answer example 3. So example 3, you should have -20, x to the 6th, y to the 4th power. Remember that when you just have a y, it's really, the base is y, but the exponent is an invisible 1. Okay, so this is all a review from last year and possibly 6th grade as well. We're going to take all these concepts now, we're going to apply them to negative exponents. So if you take a look now at example 4, we're going to follow the same exact process. Coefficients multiply. 6 times 5 is 30. The base is y. I bring the base over and I add the exponents. 1 plus -7 is -6. Okay, now at the very end, we have to recognize that this needs to be simplified based on everything that we've been working on for the last couple days, that you can't leave a negative exponent in your answer. So this has to get simplified to a positive exponent. So take a minute. It's 30 over y to the 6th power, right? It's the reciprocal. It goes to the bottom, to the denominator, and the 30 is in the numerator. Okay, same thing with example 5. We're going to multiply the coefficients. -2 times -5 is 10. And then base m, we're going to add the exponents. 2 plus -3 is -1. Base n, we're going to carry the n over. 1 plus -2 is -1. Everybody take a minute and simplify this. This gives us 10 over mn. Okay, if you have more than two terms multiplying with each other, if you have like 3 terms, you just do them all in a row. You don't have to show any work in between. The only thing to be careful of is the second term here, -a. It's very helpful to put the invisible coefficient of -1, so that when you go through multiplying exponents, you can do them all in one shot. -9 times -1 is +9. +9 times 2 is 18. Then I work on base A. Base A, I have 1 plus -6 plus 1, which is going to be -4th power. And then I have base B. I have b to the 2nd, so 2 plus -4 plus 8. That's going to give us 6. Okay, then take a minute and simplify this. You should all be comfortable at this point. Keep the positive exponents in the numerator, and then the ones with the negative exponent goes in the denominator. Okay, next. This is called power of a power. Power of a power means that you are taking an exponent, look at example 7, an exponent is being raised to another exponent. So it's a power of a power. So you'll hear yourself when you read the problem to yourself. It says x to the 3rd to the 5th. So you have to the, and then another to the following afterwards. So when you're raising a power to a power, the shortcut is you just multiply the exponents. Spell multiply correctly. Okay, So you multiply the exponent. So this would produce x to the 15th power. Okay, and the reason that happens, if you broke it down, x to the third to the fifth is x to the third times 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 x to the third, right? 1, 2, 3, 4, 5. And each time you add the exponents, right? So this would be 3 plus 3 plus 3 plus 3, so it's x to the 15th power. Okay, so obviously we're not going to write that out every time. We just take the shortcut and multiply those powers. Now, if you have a coefficient, remember coefficients are before the variable, the base, the variable. So the 3 is a coefficient. That 3 gets raised to the power as it normally would. So 3 to the second power is 3 times 3, which is 9. Okay, but the exponent gets multiplied. 2 times 3 is 6. Okay, that's different. So that's the reason why I purposely put a 3 twice in this problem. So I'm going to raise the 3 to the second power, I get 9, but then the exponent, I just multiply 3 times 2, I have x to the 6th power. So be really careful with that. That's a very common mistake to confuse those. Okay, now we're going to apply this to negative exponents. So looking at example 9, remember, you're just multiplying negative 5 times 3. Negative 5 times 3 is 15, so this is m to the negative 15th. Okay, negative 5 times 3 is negative 15. I don't know if I said that. Now that gets simplified. Remember, you can never leave a negative exponent in your answer, so it's the reciprocal 1 over m to the 15th. Okay, we're going to do the same thing like we did on example 8 with the coefficient, but now there are some negative exponents. So we have 4 being raised to the second power. So 4 squared, 4 times 4 is 16. And now I simply multiply negative 5 times 2, which is negative 10. So I have x to the negative 10th. This gets simplified, 16 over x to the 10th. Okay, they just get a little bit progressively more challenging. So there are more steps. In example 11, we now have the first term being raised to the third power. We have the second term here being raised to the second power. Those will get simplified. You'll get an answer for each of those. And then you have a multiplication problem. So then you'll multiply the first answer times the second answer. Okay, that's our game plan. So I'm going to start with the first term here to the third power. So maybe pause the video and just see if you can get the first 2 quantities that go in here. Okay, so 2 to the third first is 8. 2 times 2 times 2 follows regular exponent rules. Now I multiply. M and n both have a 1. 1 times 3, 3. And then same thing for the n. And now I'm going to do the same thing with the second term here. 3 gets raised to the second power. 3 times 3 is 9. And then I'm just going to multiply m, and then negative 3 times 2 is to the negative 6th power. Okay, now I'm going to go side by side multiplying. So I'm going to, just like I did earlier, I'm going to multiply by coefficients. 8 times 9 is 72. I'm going to multiply with the bases that match m and m. So I carry my base m, and I add those exponents. Remember, now I'm switching over to multiplication rules with exponents, which is adding exponents. 3 plus negative 6 is negative third power. And then n to the third, I don't have another n, so I just carry n to the third over. This needs to get simplified because I can't leave this negative exponent in my answer. So I end up with 72n cubed over m cubed. Okay, I'm going to stop there because the video can't get too long, otherwise it won't post. And I will continue on another video.